So we'll start with lecture number 27A, and we are going to start with three-phase circuits. So write down three-phase system. Three-phase system. Now just wait. So your single-phase system, your domestic applications like running a mixer or a cooler, fans, air conditioner, refrigerators, all work under single-phase supply because that is sufficient for that. But for the generation and transmission of electricity, of electrical power, three-phase systems are required, are universally accepted, and they are used as a standard system. All right. We say na 230 volts, 50 hertz, that's a single-phase supply. What is the standard for a three-phase supply? Anyone knows? For a single-phase supply, the standard is 230 volts, right? 50 hertz. That's the definition of a single phase. For three-phase, 450 volt, 50 hertz. That's the definition standard for a three-phase supply. Okay, three-phase systems will have three phases: R, Y, and B. All right. So how does the electricity comes to your homes? It's being generated at some place at a very high voltage. It's generated, right? Let's say 4,000 volts. Now you want to transmit. So near your areas, you might have seen these towers like this, right? Correct? They are connected at a particular distance, and these transmission lines carry that electricity. So before reaching your homes, it's connected to the transformer. It's stepped down 4,000 volts. If it comes to your home, it will burn all the appliances. So it's stepped down to 230 volts for a single phase supply, and then it comes to your homes. Okay. So for transmission of this high voltage, you require transmission lines, and for that we require three phase circuits, three phase supply. So it's used for generation, transmission, and distribution of electric power. This is your three-phase system. How does the single-phase supply look like? A single sine wave, right? This is a single-phase supply. Correct? Here you have no phase at all. But this is a three-phase supply. I'll explain it. Don't worry. Can you see the red color waveform? Can you see the colors over there? Red, dotted line, green, and blue. Okay. So first, what you do is, all of them, there are three phases. So each phase is differing from each other with a phase difference of 120 degree. Meaning, I'll first explain with the phasor diagram. Okay. So we have R phase, Y phase, and B phase. So their magnitude is same, but they differ each other with a phase difference of 120 degree. All right. Let's say R is starting first. So I've drawn my R waveform. It is like a single phase waveform, right? Magnitude is same for all. Only phase difference is 120 degree phase shift. So now, what will happen now? Which is the first one or which is the last? Can you tell me from here? Which is earliest? Which is the first waveform? You will say VR. VR is first. It's starting from 0. Which is first? It doesn't really matter. You can change this thing also. You can have R Y B or B R Y. You keep this sequence R Y B. This is the phase sequence. Just that difference between them should be 120 degree. So just concentrate over here. Oh, it's too much magnified. Okay. So first of all, we'll draw the red one curve that you can easily draw. The maximum amplitude is Vm. The minimum amplitude is minus Vm. All right. Then you take 120 degree phase shift and start to draw Vy, dotted line. But Vy we have to extend it back also. So if this is 120 degree, what will be this? 60. Correct now, because one wave is 180 degree, right? So this 120 plus 60. So it will end over here. Are you getting it? Now take another 120 degree from Vy and draw Vp. So from here you take 240 degree. So if this is 240, this will be 60 because one phase is 180 degree, one cycle. Okay. So what will be this over here? This is 60, so this will be 120, right? So this waveform will start over here like this. Are you understanding? This is how it will go on the left hand side, but you need not draw the left hand side, draw the right hand side. Alright? So everyone try to draw this waveform in your books. If you have three different color pens, you can use it. If you have a pencil, you can use it. Draw three phase supply. First start with VR, then start with VY, and then draw VB. All of them will have a phase shift of 120 degree. Yeah, this is the maximum I can maximize over here. Amplitude of all of them is same. Draw just a rough waveform, it's fine. At any point during the lecture, if you are feeling the effect of heat, you can go and drink your water. If you're feeling nauseous, go and eat something. There is no restriction on that sort. So don't wait for the lecture to get over. Whenever you feel something, you can go ahead. Okay, I will never ever interrupt you. First draw VR, then draw VY, and then draw VB. RYB. Keep this sequence. The best thing is how we can draw it or look like proper. 0 to 180 degree, draw the lines of divided into how many parts? Three parts. 0, 60, 120, 180. And keep that markings to every till the end. And then draw it. Are you understanding? So this is the marking for 120. This is the marking for 120 plus 180. That is 300 degrees. And again, similarly over here. So keep that marking same for all. You understanding what I'm trying to say? It's a little challenge to draw it, but once you understand, you can draw it. Will they ask you this in the exam? Well, you have seen in IIC exam, phasor diagram can be asked, so this also can be asked. Can we begin? Can we continue further now? If you have missed out on something, you can continue it later. We have understood the general concept how to draw it. Yeah, everyone. Can we move ahead slightly? Okay. So if you have not completed this, please complete it later. Yeah. So we have three voltages, and if I want to write in the standard form, what's the standard form? Vm sin omega t minus theta. So here Vr will be written as Vm sin omega t minus 0 degrees write it down. Vr, Vy and Vb. Vy is Vm sin omega t minus 120 degree. Meaning what? It's starting late, right? And Vp is Vm sin omega t minus 240 degree. So each of them will have a phase shift of 120 with each other. So sum of all three voltages at any instant of time will be zero. You can check it out. Use your maths and check it out. You can add these three and check it out that at any instant of point, the sum of all three voltages will be zero. Understood? You have written this expression VR, Vy and Vb. Yeah. Can we move on? So three-phase supply system will have three independent alternating quantities: VR, Vby and Vb. These three voltages, I'm just describing it. We have already explained it. These three voltages have same magnitude and frequency, but they have a phase difference of 120 degree between them. So draw this phasor diagram. Each of them having a 120 degree phase shift between them. This phasor diagram of a three-phase supply. So this phasor diagram is for three-phase supply. Magnitude wise, the length wise, they are all same. Okay, so meaning this is same as this, is same as this, magnitude wise, but the phase difference is 120 degree. Okay, why I've drawn bar? Because it's a it has a this thing, magnitude and phase. That's why I've drawn a bar vector. Okay, completed the diagram, phasor diagram. Now listen. Don't just write. Listen. Advantages of three-phase system over single phase. Just listen. So in a single phase system, I think some cuttings are there. This I have done it last semester, so I thought why not use it? I cannot dictate you this, so I have used the same PDF as I've used in the last semester. Okay, but whatever I need to tell you, I will draw it. No, don't worry about it. So you remember there is something called as a AC motor. Okay, so in a single phase system, the instantaneous power is fluctuating, hence causes a considerable vibration in a single phase motor. Have you ever been to an industry? Any industry? And have you seen a motor working? It's vibrating a lot. Okay, because the supply is not stable, it's AC, continuously AC. But if you have a three-phase system, the instantaneous power is constant all the time. Have you ever operated a mixer? You have to really hold it and it vibrates a lot. If you have used a three-phase system over there, but you don't use it, that vibrations would have been very less. Three-phase system will have, here it is written 315, so sometimes it's also 315. Output of a three-phase system is 415, 50 hertz, greater than the single-phase supply. What's the advantage of it? First of all, if I compare the residential area bill, it's around 5 to 6,000. It comes average bill per month. In an industry, if they use a three-phase system, the bills comes around 40 to 55,000. Just 10 times difference. That's it. Not much. But the industry people earn that much also, right? If they can afford 40, 45,000, they are doing a business in lakhs, of course. Three-phase motors are more efficient and are having a higher power factor than single phase running at the same frequency. What's the meaning of this? If any system has a higher power factor, now by now you understood what is a power factor? Reactive power is minimum and a power factor is high. Have you seen, have you bought an air conditioner or in the process of buying an air conditioner or a refrigerator or a washing machine? Do you see there are 3-star rating, 4-star rating and 5-star rating? 3-star rating refrigerator is, let's say, 20,000. 4-star rating is 25 and 5-star rating is, let's say, 32,000. Why there is a price difference? What they will say, the person will say that 5-star rating hai, it will consume less power. Is it true? Yes, it's true. Because that three-phase, that 5-star rated, 5-star rated refrigerator will consume less power because inside there is a circuitry which will make the power factor higher. So losses come again. That's why it's 5-star rating. So for the same air conditioner or a refrigerator working with a 3-star rating and you compare it with a 5-star rating, there will be a difference of 200 to 300 rupees in your energy bill. Initial cost will be 10,000 more, but later on in the longer run, it will be beneficial. I'm not promoting 5-star and all that, but this is the reality. That's what they do it internally. That power factor of that entire system is higher. Technically, that is what it means. Yeah, so transmission and distribution, three-phase system is cheaper than the single-phase system because your three-phase system will require less copper than a single-phase system. I'll explain you how later on. Okay, now write down three-phase system terminology. Write with your pen. Mobile phones, you can keep it aside. First, write down phase sequence. So I'll tell you to don't write the definition, just write the main heading, that is phase sequence, and I'll explain. The order in which, listen to the wordings, the order in which the voltages in the three phases reach their maximum positive value is called as the phase sequence or phase order. So have you seen that diagram over here? Which waveform is reaching the maximum value first? VR, then Vy, and then Vb. So again I repeat, phase sequence is the order in which the voltages in the three phase reach their maximum value. And what was the order? R by B. So R by B is my phase order or phase sequence. So write down example over there. R dash Y dash B is my phase sequence. Alright? R Y B is the phase sequence. Can I move on to the next one? Phase voltage. Now, listen carefully. I have explained you this for the generation of AC signal. There was only a one. What was there over here? What is this R dash called as? Coil. One rectangular coil was there in a single phase system, and it was cutting the lines between the magnetic lines of flux between north pole and south pole. And whenever it cuts, it creates a magnetic flux and a EMF is induced, right? यहाँ पे एक की जगह तीन कॉइल है, R dash, Y dash, and B dash. We are not explaining the generation, but the three coils are R dash, Y dash, and B dash. The concept is same. Whenever one of these coils are coinciding with the magnetic lines of flux, phase difference is zero. Whenever, let's say, this is my magnetic lines of flux, and if the coil is like this, I have a maximum induced in the EMF. If the coils are in parallel, phase difference is zero and EMF will be zero. Okay. If the coils are like this, phase difference will be maybe 45 degrees. Are you understanding? So whenever these coils coincide or cut the magnetic lines of flux, EMF is induced. Which law? Faraday's law. Yeah. So write down over here. Next one is phase voltage. The voltage induced in each winding is called phase voltage. Write it down. Read this, write it down. V phase, VPH, the voltage induced in each winding is called phase voltage. So how many phase voltage you will have? 3 for R, Y and B. Okay. Next is phase current. Just write phase current, IPH. The current flowing through each winding is called phase current. The current flowing through each winding is called phase current. Okay. Phase voltage, phase current, understood? Now write down a definition for line current. Line current VL. Line voltage VL. The voltage available between any pair of terminals or lines is called line voltage. The voltage available between any two pairs of terminals or lines is called line voltage. The voltage available between any pair of terminals is called line voltage. I'll explain you with the diagram, don't worry. Then line current, the current flowing through each line is called a line current, IL. Just write line current and bracket IL, that's it. Completed? All the terminology, phase sequence, phase voltage, phase current, line voltage, line current. These are the only things which are of interest in case of a three-phase system. Can we start? Now write down the next heading: symmetrical or balanced three-phase system. Symmetrical or balanced three-phase system. Now I will make you write this because this is important. Whatever I'm making you write, they can be asked, high possibility in exam. Write down: a three-phase system is said to be balanced if a three-phase system is said to be balanced if there are three conditions. Voltages in the three phases are equal in magnitude. It's written over here. A three-phase system is said to be balanced if voltages in the three phases are equal in magnitude and differ in phase from each other by 120 degrees. Okay? You don't write second point. Wherever you have written current, just write slash volt. Wherever you have written voltage, just write slash current. So first, second point covered. Okay? Understood? So second point is currents in the three phases are equal in magnitude and differ in phase by each other by 120 degree. So first and second point almost same. Just write voltage slash current. Write down third point. The loads connected across the three-phase system are identical. The load connected across the three-phase system are identical. The load connected across the three-phase system are identical. That is, all the loads have same magnitude and power factor. ये लिखो, ये जरूरी है. The third condition is important. The load connected across the three phases are identical. All the loads have same magnitude and power factor. Okay? Now, in a three-phase system, you have two types. One is star connected and one is delta connected. So write down first star connection three-phase. Write down star connection three-phase. Now, I'll help you out in understanding how to draw a star connected three-phase. So how many windings are there? How many coils are there in three-phase system? Three. R dash, Y dash, and B dash. All right. So let's draw it. It's a coil. So it's like an inductance. So how will you represent the coil? Let us draw it properly as a coil. Okay. So this point I'm calling it as R. This is Y, and this will be B. All right. What is this name as? R dash. This we can call it R dash. This will be B dash, and this will be Y dash. The diagram which I have showed you earlier. Okay. This is R, this is B, and this is Y phase. Do you know what is this point called as? Middle wala point? Neutral. Have you heard of this? Neutral. So this is neutral point N. Write down over here. Neutral point. And what is this? What is this thing called as? This is called as three-phase star-connected supply. What is it called as? Three-phase star-connected supply. I won't be drawing it again and again. So I'll be just showing you this is the three-phase supply. So three-phase supply means you have to draw this. Are you understanding? Ye supply hai. You know, just as in single-phase supply, what do we draw? Like this, na? In a three-phase, this is drawn. Samajh mein aaya what I'm saying? This is for single phase. Okay, is this clear to you? Now, let's draw a three-phase system along with the. Now, if it is a three-phase system, you will have what connection is this, star or delta? Star, na? So you have a star connected balance load also. So now you draw. Now we are drawing now a three-phase star connected system. System will consist of supply and the load also. So let's draw it together. Okay, so let's start with the supply. So kindly draw the supply over here. Okay, so for the supply we have what? R. This is R. This is Y. Oh, complete and draw that supply. Minus a little stuck. Yeah, it's coming now. Okay, so this is my R, P, and Y. What is this point? Neutral. Now, how will I connect a star connected load? See here, same way. Star connected load I'm marking in blue in color. So you will take the connections from here itself. What are these? R. This is okay. What we do over here is we connect B first and then we connect Y. So Y will come a little down. We'll go follow the same sequence, right? This way. So this will be B and this will be Y. Alright. Now over here, I will be connecting my. Now, if I have a three-phase load, need not be it's a resistive load, right? If I write Z, it's okay. It can be resistive, capacitive, or inductive. So I will write express over here. Instead of writing anything, I'll write it as Z phase. Z. Z is my impedance. So connected in the same fashion. Z phase, all the things should be same. Z phase. This will be going to P. This will go to Y. And this will go to R. There is one more thing which will go. Neutral. Where is neutral for this? Here. So these also are connected. So this is neutral. So this is R. This is Y. And this is P. This is neutral. Okay. Please draw it. So I have a star connected three-phase supply and I have a star connected load. You're drawing along with me, right? So this side, this we call it as three-phase star connected supply. And this is called as the load. So three-phase star connected balance load. Why do you call it balance load? Do you see I have written over here Z phase everywhere. Sodium magnet, this thing is same. Impedance is same for all. What is different? They have the same impedance and same power factor also. Meaning if Z phase is RL, a coil, R and L. Later on, I am recording the lecture. So Z phase will have the same power factor also, meaning if Z phase is RL, a coil RL, this also will, all three will be RL coil only, having the same power factor. Okay, that's why it's a balanced load. So this is three phase star connected balanced load, and the entire system is called as three phase. How many wires are there? Four wire, R, Y, B and N. So three phase, four wire star connected system. Write down. Okay. Now, how will you mark the currents over here? I have told you now there are phase current, phase voltage, line voltage. So how will you mark phase current? So this is IR, this is IY, this is IB. And for the neutral point will be IR plus IY plus IB. All the three current meets as a neutral point. Normal KCL, right? Incoming current is equal to outgoing current. So write down this currents. Can you tell me what will be Z phase? General format, R plus minus JX. So X can be 0, it will be resistive. It can be R plus JXL, inductive, or it will be R minus JXC, capacitive. So any three are possible. R plus JXL, R minus JXC. Okay? Written? Now your three line currents are below the system. Write down whatever I'm telling you to write. This system is understood now? You have it in your books now? Now let's proceed ahead. Three line currents are IR, IY and IB. Three line currents are IR, IY and IB. Obviously IR, IY and IB will be Im sin omega t minus 0. No need to write that, that is understood. Next point is current flowing through the neutral point is the addition of all. IR plus IY plus IB is equal to 0. You want to check this out, how it is so? All are moving out and all are, entering the neutral terminal. So IR plus IY plus IB is equal to 0. Write it down somewhere. This one. Current flowing to the neutral wire is 0. We say that the neutral wire doesn't give a shock because it's a current doesn't flow in a neutral wire. So current doesn't flow in a neutral wire only if the load is balanced. अगर load imbalance हुआ and you touch the neutral wire, you will say sir आपने तो बोला था current flow नहीं होता है, पर मुझे तो shock लगा है. The load was not balanced in that case. If the load is imbalanced, you will get a great shock. So if the load is balanced, the neutral wire carries zero current. If there is a big if. Okay. Now let's talk about line current. Let's talk about phase voltage and line voltage. Up till here clear? Okay. So here it is. Okay. So listen carefully. Concentrate over here. I require your concentration for some more time. R by B is my three phase supply. I'm not drawing over here. I'm just writing R by B. Okay. What is this I have drawn? Three phase star connected balanced load. So you have written R, B, N and Y. See, it's easier to represent in this diagram because there are a lot many quantities. So this voltage over here, I'll maximize it. What is the voltage between V? Acha, what is the phase voltage? VR, VY and VP, right? That is understood. Now I'll tell you what is the line voltage. See, from here to here, between the lines R and Y, what is the voltage? VRY. And what was the definition of a line voltage? Voltage is between any two terminals or lines is called as a line voltage. So VRY is a line voltage. Then next VYP is the line voltage, and then next VBR is my line voltage. Understood? Why not RB? Why VR? I'll tell you. R, Y, B should be followed, na? R, Y, B. So first voltage is VRY, second voltage is V by B, next voltage is VBR. Understood? Follow the same sequence. VRY, VYB, and BR. So mark this much. So what are these things? These are line voltage or phase voltages? Line voltages. What is phase voltage? VRN. R with respect to neutral. So VRN, VYN, and VBN measured with respect to neutral point. Okay. So write down over here VRN, VYN, and VBN. N means what? Neutral point. Are phase voltages, and VRY, VBR, and VYB are line voltages. Acha, I'll show you the phase voltages over here. See here. This is neutral point now. So this is VRN. This is phase voltage. This is a neutral point, right? So VBN is my phase voltage, and over here VYN is my phase voltage. So all the phase voltage I'm highlighting with yellow color. They are measured with respect to neutral terminal. Understood? All the line voltages I'm marking in green color. Simple है. Phase voltage are measured with respect to phase and neutral. Line voltage are measured with respect to each other. RY, YB, and BR. Alright? Now line current. Here in a star connected network, line current and phase current are same. So write this down. What I have written on the left hand side, right hand side, please write it down. IR, IY, and IB are phase currents. That is equal to line current, IL or IBH. So line current and phase currents are same in a star connected system. Completed? Have we understood? How do we measure phase voltage, line current, and phase current now? Okay? Now, listen over here carefully. As the load is balanced, V phase, all the phase voltages are same. If the load is balanced, right, all the phase voltages are same. Meaning what? If all of them are Z phase, are equal, then VRN, VPN, and VYN are same, right? So let's call them all together as V phase. Okay, all of them are same, so let's call them as V phase. But only what is same? Magnitude is same. They have a phase difference of 120 degree between each other. You know that, right? So write down this. VRN is V phase angle 0. VYN is V phase angle minus 120. VBN is V phase angle minus 240 degree. Okay? What are we doing is we are establishing a relation between line voltage and phase voltage. Have you written this tree? These three have written. The magnitude is same. Magnitude is called as V phase. Phase difference is 120 degree. Okay? Now, line voltages are what? V R Y. See, again I repeat, R Y P. So first voltage is between these two. Second voltage is between Y. Third voltage is between P and R. Okay, so VRY, VYB, and VBR. So for balanced systems, line voltage VRY, VYB, and VBR are all same, right? But now we are establishing a relation between line voltage and phase voltage. So here VRY can be written. Can we write VRY as this? VRN minus VYN. Can we not write this? अरे देखो ना, VRY Can we not write it as VR minus VY? Correct. Now, instead of VR minus VY, I am writing it as VRN minus VYN. Okay? So if I want to make this plus, if I want to make VYN as plus, I can write it as plus VNY. VNY becomes plus. So I write it as VRY is VRN plus VNY. Okay? Or we can write it as VRN minus VYN. And what is VRN? V phase angle 0. Just listen, don't write. I'll tell you to what to write. Then V, what is VYN? We have written over here, no? V phase angle minus 120 degree. Now, you can easily, this is polar form, right? Polar form we cannot add. We have to convert into rectangular form. So if you convert this into rectangular form, this will become, let me magnify it. So this will become V phase plus Z0, J0, and this will become, you can convert this 1 comma minus 120 degree, it will become minus 0.5 V phase minus J 0.866 V phase. You can check it out. And then when you add them together, you will have 1.5 V phase plus J 0.866 V phase. And finally, again you will convert it back to polar, you will get VRY as root 3 V phase 30 degree. What's the meaning of this? The phase difference between, what is VRY? Line voltage. And what is V phase? Phase voltage. So the angle between, the phase difference between the phase voltage and the line voltage is 30 degree. And what's the magnitude wise difference? Root 3 times. Line voltage is higher than root 3 times the phase voltage. And angle phase difference is 30 degree. Okay. So write this one example. So write that VRY up till here. Complete it fast. Others I'll explain it. But this you write. Yeah. What are we writing? Deriving the relation between line voltage and phase voltage. So what's the relation? Line voltage is root 3 times phase voltage, angle 30 degree. Completed? Okay, I'll give you all a minute. Someone please do the conversion and check now. One angle minus 120 degrees, is it minus 0.5? Can they ask you in the exam? Derive the relation between phase voltage and line voltage for a star connected system? Yes, they can ask you in the exam. Completed? Have one of you checked it in the calculator? Is it same? All right. So similarly, write this down expressions below also. Similarly, V by B is what? VIN plus VNB. That is root 3 V phase angle 30 degree. VBR is again root 3 phase angle 30 degree. So write down all three expressions. This also write down please. Write down V by B, VBR, everything. Completed? Okay, so can we write general expression now? In a star connected three phase system, line voltage leads the phase voltage by 30 degree. And what's the relation? VL is root 3 times V phase. So write down this also. Line voltage is root 3 times phase voltage. And line current is equal to phase current. Very important for numericals. Now, yeah, above. VRY, VYB and VBR are all same now. So VL is root 3 times V phase and IL is I phase. Now the most important and challenging is drawing the phasor diagram for this system. Okay, draw the phasor diagram for this system. Meaning, what are the phase voltages difference between them? 120 degree, right? अभी line voltage भी बनाना है. So the phasor diagram will contain